So we're going into our last section for Module 1, which is Module 1.5, Composite Functions. That should be a familiar phrase to you. We've already learned how to calculate those. Now we need to teach you a different way that you might see them written. So students will be able to calculate the value for a composition of two or more functions and describe their relationship to one another. We have already done this in class where it may have looked like f of g of x. This is something that I think a lot of you need a little bit more practice on. Hopefully by the time we're getting to this section of the module, you'll be fairly good at it. Compositions of functions is when one function is inside of another function. The notation used for that can look like this. More commonly, you're going to see this. F of g, that's a little o. It's a little kind of an open circle. It's not an O and it's not a dot. It's kind of an open circle. F of g of x. These two symbols mean the same thing. You're going to see this quite a bit. So what does that mean? F of g of x means a composition of the function f when g is defined as the following. And g would be the input. G's output is f's input, just like we were doing before. Okay? So exactly the order you see the f and the g here is the order that you will write them in your notation form, in your function form, excuse me. So why the order is important? F of g of x means the function f is using the g of x quantity as its input. The reverse of that is if you have g of f of x, the g function is using the f output as its quantity for the input. Okay? So, how do you do that? Especially now we're dealing more with polynomials than we are with straight numbers. So the first thing you're going to do is write it in a different form, like we had up here. So you would have f of g of x would be written as f of g of x. Okay? So whatever the occurrence is for g of x is going to be placed as the input for the f of x function. So let's show you an example down here. Once you see it, it'll make more sense. So in this case, we're doing f of g of x. Find f of g of x. So our g of x, this amount here, is what's going to get substituted in for the x there. So f of g of x. Here's my f function, negative 4, x plus 9. However, my g, what it is equivalent to, my g of x is going to be my input. So 2x minus 7 plus 9. So this amount is becoming the input. Then you just simplify. So you would get negative 8x plus 28 plus 9. So when you simplify that, you'll get negative 8x plus 37. So f of g of x equals negative 8x plus 37. Exactly like you've done before. Now you're dealing with variables, in this case more than you are with straight numbers. Exactly the same premise as f of g of x. Exactly the same. Okay? Let's do some practice on those. If you're just careful about how you set these up, usually these are not problematic. So, okay, if f of x equals negative 4x plus 9 and g of x equals 2x minus 7, find g of f of x. So now ask yourself, what's going to be the input and what function are you inputting it to? So now, because it's g of f of x, this negative 4x plus 9 becomes the input for that function, 2x minus 7. Okay, so we're going to plug in negative 4x plus 9 minus 7. And we'll get negative 8x plus 18 minus 7. So our g of f of x should equal negative 8x plus 11. So I want you to really notice, this is important. Notice that example 1 and 2, the functions were exactly the same. But when I took f of x and when I took g of x, it came very different answers. Okay? F of g of x gave us an answer of negative 8x plus 37, whereas our g of f of x gave us negative 8x plus 11. Okay? And this is really important. The way we write down the problem can make a big difference in our answer. That is important. That's something you need to be very mindful of and be very careful of. Okay? Here's 3 more practice problems. I'd like you to hit pause on the video, come back and check your work, please. Okay, now that you've done examples 3, 4, and 5, let's check them. So, number 3, we're finding g of h of x. So, we're finding in our g function is 2x squared minus 7x. The input for that is going to be our h function, which is 3x minus 5. So everywhere we see an x here, we're going to put in 3x minus 5 minus 7 times 3x minus 5. Okay? To simplify that, let's use the trick I showed you in class. 2 times PEMDAS makes us do this first. 3x squared is 9x squared. Negative 5 squared is 25. 3x times negative 5 is negative 15. We need to double that for the middle term, so we get negative 30x. Simplifying this parentheses, we get negative 21x plus 35. Simplifying and getting rid of that parentheses, we would get 18x squared minus 60x plus 25 minus 21x plus 35. Simplifying final time, we will get g of h of x equals 18x squared, it's the only one we have, negative 60 and negative 21 is negative 81x, 25 and 35 is 60. Okay. Going on to example 4, we're finding h of g of x. So h of x equals x cubed plus 4. We are inputting this as our input, so we would have h of cube root of x minus 4 into everywhere we see an x. So cube root of x minus 4 cubed plus 4. When we cube a cube root, those will cancel out. So we will just get x minus 4 plus 4. So in this case, this is just we're going to want to put a star next to this. H of g of x equals just x. When the composite function equals x, it also tells us that the functions are inverse. Remember, back in another section we were already doing inverse functions. When the composite function equals x, so when we do h of g of x, if we did g of h of x, we would also get x in this case. Then the functions are inverse. Okay, make sure you get that down. And let's go check our last example. If f of x equals negative 2x plus 9 and g of x equals negative 4x squared plus 5x minus 3, find f of g of x. So again, our f of x function equals negative 2x plus 9. Our g of x is becoming the input. So anywhere we see an x, we're going to put in negative 4x squared plus 5x minus 3. So we'd have negative 2. Here's where we're plugging that in. Negative 4x squared plus 5x minus 3 plus 9 for that plus 9 up here. Let's go ahead and simplify that out. So we get 8x squared minus 10x plus 6 plus 9. So our f, let's write it this way, f of g of x equals 8x squared minus 10x, 6 plus 9 is 15. Okay. That is it for Module 1.1. I would strongly suggest that prior to our quiz on this module, you go over all the notes, you go over any types of problems that you feel you need practice on. I would do extra practice out of the book if you haven't done so already, and I would also go over the modules that we've done in class. Any and all of that is required knowledge for the quiz. Okay? Thank you. If you have any questions, let me know.